Hello, welcome to this lesson. In this video, you're going to solve this question I have on the screen. So for this question, we are going to find a particular solution to this question given that y is equal to 3 when x is equal to 2. So we have this differential equation 1 plus x squared dy dx, okay, to be equal to 1 plus y squared. So the first thing we have to do is to do separation of variables, okay. So let's look at how we are going to do this. So I will start by multiplying through by the x. Okay, so when I do that on the left hand side, you're going to have 1 plus x squared dy. Okay, and this will be equal to 1 plus y squared, 1 plus y squared dx. Okay, alright. So what I'll do next is that I will divide this side by 1 plus x squared, and then same here, 1 plus x squared. So when I do this, I can cancel out this from the left hand side, okay. And then when I'm done, we're going to have something like this: 1 dy equals 1 plus y squared over 1 plus x squared dx, okay. But I want this y expression here to go to the left hand side, okay. So for that reason, I will multiply through by 1 over 1 plus y squared. Okay, when I do that, we are going to have 1 over 1 plus y squared dy on the left hand side, and then on the right hand side, we are going to have 1 over 1 plus x squared dx. So from here, we are done with the separation of variables. So the next thing we are going to do is to integrate what we have, okay. So I will bring the integral symbol on both sides. Okay, so when I find the integral of 1 over 1 plus y squared with respect to y, that will give us tan inverse of y, okay. And then on the right hand side, we are going to have the tan inverse of x, and then we can bring the constant of integration. Okay, one thing you have to know is that when we find the derivative of tan inverse of x, okay, that's when you find the derivative of the tan inverse of x with respect to x, you are going to get 1 over 1 plus x squared, okay. What this means is that if you find the integral of this, then you are going to get the tan inverse of x. That's what I applied here, okay. Let's take note of that. Okay, we are going to continue. Okay, so now what I want to do next is that I want to get the equation to be in terms of tan functions, okay. So I'm going to write the constant c as tan inverse of k, okay, tan inverse of k. So for this reason, you can write tan inverse of k in place of c. So you're going to have tan inverse of y to be equal to the tan inverse of x plus the tan inverse of k. Okay, so that you can have the equation in terms of tan. Okay, so from here, what I'll do is that I'm going to introduce some variables. Okay, so I will say that let the tan inverse of y, okay, let the tan inverse of y be equal to a, and then the tan inverse of x be equal to b, and then the tan inverse of k, to be equal to d. Okay, so this is what you have. So from here, we can write this equation that I have here. You can write it. So we know that tan inverse of y is equal to a. So you're going to have a equals the tan inverse of x plus tan inverse of k. So that will be equal to the tan inverse of x is equal to b. So you're going to have a equals b plus the tan inverse of k, which is d. So That would be A equals B plus D. Okay, so from here, what you are going to do is that, yeah, I'm actually doing this so that we can get rid of the tan function, okay, so that we can write our answer in term as y in terms of x, okay. So like I said, I want to get rid of the tan function so that we can write our answer as y in terms of x. Okay, so let's look at how we are going to do it. So we are still in the process of getting rid of the tan function. Okay, that's why we are doing all this. Okay, so the next thing we are going to do is that we are going to introduce tan function to both sides. Okay, so when you do this, you're going to have tan a. Okay, tan a to be equal to the tan of a, sorry, the tan of b plus d. Okay, this is what you are going to have. Okay, so what you are going to do next is that on the right hand side, you see that you have the tan of a compound angle, okay, because you have b being added to d, so we term this as compound angle, okay. So because we are finding the tan of a compound angle, we can use the compound angle formula for tan, okay, in place of what we have here, so that we can be able to find the solution. So instead of using tan b plus d, okay, you are going to use an identity, which is the compound angle identity formula for tan. So let's look at that. So that is giving us, if you have tan of if you have tan of, let's say, x plus y, okay, this will be equal to tan of x, okay, plus tan of y, okay, divided by 1 minus tan of x multiplying tan of y. Okay, so this is the compound angle identity for tan. So this is what you are going to use. So from here, you are going to have tan a. You're going to have tan a to be equal to tan b plus tan d. Okay, let me try and put this in bracket. Tan b plus tan d divided by 1 minus tan b multiplying tan d. Okay, this is what you are going to have. Okay, so let's go back to the variables we defined. Okay, so we said that tan inverse of y is equal to a, right? So that tells us that y will be equal to tan a. Okay, and then also x will be equal to tan b, and also k will be equal to tan d, right? Okay, so now we can substitute this into what we have here. We can do that substitution. Okay, so let's look at that. So we have tan a on the left hand side, and then we know tan a is equal to y, so we are going to have y equals tan b, and tan b is equal to x, so we are going to have x plus tan d, which is k, so you are going to have x plus k. Okay, divided by 1 minus tan b, which is x, multiplying tan d, which is k, so we are going to have minus kx. Okay, this is what you are going to have. So since this contains the constant k, we will call this as the general solution. Okay, but this is not the solution we want because it contains the k, and we want to find the particular solution. So we can now bring in the conditions that were given to us. So we have y to be equal to 3 when x is equal to 2. So we're going to have 3 to be equal to 2 plus k, okay, divided by 1 minus k multiplying 2, so that will be 2k. So now let's simplify this. So I'm going to have 3 multiplying 1 minus 2k to be equal to 2 plus k. So this will be 3 minus 6k, that will be equal to 2 plus k. Then let's simplify this. When I do this, we're going to have 3 minus 2 to be equal to k plus 6k. Okay, so on the left hand side, I'm going to have 1. Now on the right hand side, I'm going to have 7k. So this will be equal to, I'm going to get k to be equal to 1 over 7. Okay, so from here we can substitute k into the general solution so that you get our particular solution. So let's look at that. Okay, so you are going to have y, you're going to have y equals x plus k, but k is now 1 over 7. Okay, and then divided by 1 minus kx, which is 1 over 7 multiplying x. Okay, so let's simplify this. So I can write this as x plus 1 over 7. Okay, x plus 1 over 7. And then this x plus 1 over 7, we can actually simplify this to, let's do this. Okay, let's focus on just the x plus 1 over 7. Okay, so we have something like this, x plus 1 over 7. Okay, so the common denominator will be 7. Then you're going to have 7x plus 1, right? And then for the denominator 2, you're going to have 1 minus 1 over 7x. Then you're going to have 7 here. So you're going to have 7 minus x. Okay, 1 times 7, and then x times 1, because you're going to have 1 over 1 here. So you're going to have 7 minus x over 7. So then you're going to have something like this, 7x plus 1 over 7. Okay, divided by 7 minus x over 7. So you're going to reciprocate this thing. Okay, so let's look at that. So reciprocating the second term on the left hand side, okay, that's this term. You're going to have reciprocating this term, okay, you're going to have this to be equal to 7x plus 1 over 7 times 7 over 7 minus x. And you see that this 7 will cancel out this 7, and then at the end, you're going to get y to be equal to 7x plus 1 divided by 7 minus x. Okay, so this becomes the particular solution to the differential equation that was given, giving the boundaries to be y equals 3 when x is equal to 2. Thank you very much for watching this video. If you find this video very useful, please make sure you like the video and subscribe to the channel for nice videos like this. Thank you.